So, I've got a bit of a confession for you. Hello guys, Jordan here from Artisan Electrics. Welcome back to the channel. So, I've got a bit of a confession for you. Do you want to hear it? So, as most of you will know, my regular subscribers, about a week ago I posted a video of how to quote for an EV charging job, where I showed you around a potential job that I was doing for a customer, and I asked you how would you do it. I kind of showed you the way I was thinking of doing it, and I asked for your comments about how much you would charge to do the job. I'm here today and I'm about to do the job, but the confession is, it's not just any old customer, because today I am the customer. So I'm installing my own electric vehicle charging point today. I've got a Tesla Model 3 arriving the day after tomorrow, and I've got my charging point to put in. So I'm going to be installing a MyEnergy Zappi charging point today. That was my go-to charger of choice, just because of quality and safety reasons and the ease of installation. So I'm going to be putting one of those in today. So I'm going to show you around and show you how I install my own EV charger. So here we are at my house, and this is my usual van parking spot. Here's where I usually park the car. But the EV charging point is going to go on the wall here, just because I think it looks neater to put it here rather than actually installing it on this side. And also this side would be a lot further cable run. The Tesla, usually I would park it here and the charging point would be on that side, but I think I'm going to just swap things around, move the van to here, and then start parking the Tesla here. So the charging point will actually be here, which is really easy to reach from this point. So I've got the Zappi in the back of the van. I'm going to get that out in a minute and start marking up, but basically my idea is to put the Zappi on the wall here, armoured cable run surface clipped down and then along the wall here, drill through in this little corner here behind, just take out a little bit of the mortar behind that concrete post, then through this gate, so it will come behind that gate, it will clip along, and actually here is the stairs, so the stairs go up like that, and the cupboard under the stairs, this corner of the cupboard under the stairs starts about there, and then the consumer unit is just back to back pretty much with the electric meter box there. So it should be fairly easy for me to actually run the cable mostly inside in the cupboard under the stairs, which is just like a utility cupboard, run it along inside and then drill out at an angle, and I should pop out about here somewhere so that the cable's only running on the outside for as short a distance as possible, just for neatness. I would have really liked to have just hidden it in this gravel, but as some of you pointed out, there's no way of digging it 60 centimeters deep into the gravel. So just to be safe, I'm just going to clip it all up so that it's visible. Safety wise, obviously we've got the gas meter box here. The boiler is on the other side. We've got a main bond for the boiler, so that's fine. We've got a 100 amp main cutout fuse. So this will be a job where I can connect and then notify afterwards the DNO to let them know that I've put in an EV charger. It is a PME system, so TNCS, basically that means that usually an electric vehicle charger would either need a earth electrode for the charging point only, so that it has its own TT earth, or you would need to put in some kind of pen fault detection device like a MATI device. However, in this case, the Zappi has its own built-in pen fault detection, so it's super easy, and it's got its own built-in RCD protection as well. So I'll show you inside here. Basically, this is the utility cupboard, As I said, we've got the boiler here and the main bond for the gas is there. And then this is the consumer unit. So I'm going to have to remove this washing machine to be able to get access properly to clip the cabling and stuff. But consumer unit here, we do have a spare circuit, this one here. That one is going to be used for wiring up the shed, so I'm keeping that one spare. However, these circuits are both off the RCD, and I don't want to have an RCD off an RCD because that could cause issues with, for example, DC currents jamming up one of these RCDs if we've got DC feedback from the charging point. So what I'm going to do is just reconfigure this board. I'm going to move this RCD across one module and put the MCB, I've got 40 amp type B MCB to go in, that's going to go in there straight off the main switch. So that this particular circuit is just straight off the main switch. I've got a little bit of copper buzz bar to go in here, and then I will have to just relabel everything so that it's all labelled properly when I shift the circuit breakers across. Basically this spare will then disappear and these 5 will just shift across to here. So yeah, it should be a fairly straightforward little job really. In terms of maximum demand, we're fine. We've got an electric cooker and hob, which is probably the largest consumption in the house. It's just a little 3-bedroom semi-house, but there's only the 2 of us living here, so we don't use that much electricity. So we've got plenty of spare capacity in terms of maximum demand, so I'm not worried about blowing the main fuse. But if I was, the Zappi has its own built-in load limiting function anyway, so I'm going to set that load limiting function to 100 amps so that there's no way that the Zappi can actually push the main demand for the installation over 100 amps and blow the main fuse. So I'm just going to pull this out now and make myself a little bit of space and then get cracking. Right, so as you can see the cupboard's nice and clear now, and basically what I'm going to do is just come straight out the bottom of this consumer unit with the armoured cable down there, clip it along to that corner and then drill through an angle and come out somewhere on the other side. So I've got my tape measure here. I'm going to just measure the whole width of this cupboard so that I can figure out exactly where the end of this cupboard matches on the other side, and then I'll probably drill in from outside just so that I've got a nice neat hole on the outside, because on the inside here it's hidden behind the washing machine anyway. It doesn't matter so much if I blow out the plaster a little bit. I can just make it good and fill around it and silicone it and whatever. Right, I've got about 2.6 meters here. So I'm going to go on the other side now and see where that actually lines up with. Right, so 2.6 gets me just to where the gate is basically, which is quite nice because if I drill at an angle from inside out or outside in, I'm going to be hidden just behind the gate when the gate is open. So that's good. I want to drill at an angle so that when the cable comes out I can clip it in a nice straight line. And in terms of the height, I need to be about 15 centimeters from the finished floor in the house, and that will be about 30 centimeters from the outside paving here. So if I come in this course, just on the bottom of the meter boxes, this course here, that's the one that I want. So I've got these really long drill bits that I like to use. This is my course here. What I like to do is just drill a pilot hole first usually, and then open it up. So I'm going to have to take the gate off its hinges because I've got not enough room to drill at an angle. This gate's rubbish anyway. Right, so what I've done is I've measured across there 2.6 meters, which takes us to about here. Then I've measured an extra 20 centimeters across so that it's just behind the gate. That takes us to here. And I'll drill in at an angle. The wall's about 25-30 centimeters thick. So if I get the angle right, I'll pop out exactly in the corner of the cupboard, which is hopefully what I'll manage to do. So let's see, we're through, so let's see how we manage to get on. There we go, not bad, eh? So that'll be perfect actually. That can come through there, just clip along here neatly, a little bend up and into the bottom of the consumer unit. So I'm quite happy with that. Not perfectly in the corner, but it's pretty good, and it's not popped out much of the plaster, which is the main worry that I had. So now what I need to do is just open that hole up a bit with a larger drill. That's just opened it up to the kind of size that I should need. Obviously it's a 16mm drill bit, but there's a few mil of play there. If you sort of drill it in and out a few times, it'll open it up slightly more. So we'll give it a go and see if we can get the 6mm cable through there now. Is that going to be enough? Close. Ah, look at that. It's just going to be too short. Typical. Okay, try again. I never really know what to do with all these offcuts, because you kind of think, I'm sure they'll come in handy at some point. But you end up getting a massive pile of them, and then they take up a lot of space, and other halves tend to get irritated by that, as you all know. Right, so I've just warned the missus that I'm going to turn the power off, and so what I'll do is just take this opportunity to do an RCD test as well on these. Turn all the circuit breakers off, and then main switch off, and I'll go to the main isolator outside and just isolate the whole lot. As I mentioned, so we've got a 100 amp main fuse here. Main switch is here, so I'll just flick that off now. PME supply. It used to be a TNS by the looks of it, someone pointed out to me, and then they've converted it to PME when they've done the cutout upgrade or something like that. Now I posted a message out on Instagram about this consumer unit because I was actually not sure what brand it was, and I had loads of replies, like literally hundreds of replies, so thanks to all of you who messaged me about this. And basically it's LINIAN, but they sort of took over a brand called Control Gear, so this is the old Control Gear branding. And somebody, one of my Instagram followers, really kindly told me that he had a breaker lying around in his shed that he didn't need, and so he sent it over to me for free, which is really kind. So thank you for doing that. And if you don't already, head over to Instagram and follow me on there, because I post on Instagram pretty much daily stuff that I'm not putting on my YouTube channel. So if you're interested in all that. So the board's been fairly neatly done. My landlord is an electrician, believe it or not, so he knows what he's doing. And what I'm going to do is just try and take out the spare breaker here and then shift everything across and put this new breaker in the middle there. Now, because I'm working on my own house, I could easily be complacent about safety, but I'm not going to be. So I'm going to still carry out safe isolation procedure, just to make sure that everything's dead before I start working on it. So that's all fine. Awesome. So we're safe to work. So I'm going to flip this buzz bar cover off. And what you can see here is just really nice, is that there's basically This is one of those adaptable boards that you can shift around, and he's left a little bit of buzz bar just in the bottom here so that I can use that for the main switch, so I don't need to buy a special piece of buzz bar, which is really nice. So this is the spare breaker here, which I'm going to get rid of, but it's connected to this RCD here. So I'm going to have to cut that short, and then literally I will shift all of this across to the right by one module so that I can fit the new MCB in there. So it should be fairly straightforward, but I've got to just remove this buzz bar, and then I can get rid of that spare circuit breaker, that 16 amp one. There we go, like that, and then shove that one out like that, and then all of this should just shift across, hopefully. Yeah, pretty easily. And that shifts across enough for me to get my 40 amp breaker in there, yeah, which is all I need really. I'll just shuffle across a little bit more probably, there we go. That's great. So then this little piece of mini buzz bar, I just need to cut that so that it's just a one-way rather than a two-way. And usually you can just do that with a pair of side cutters and just sort of bend it off, and that works fine. And then, or with a hacksaw maybe is better. And then this one, again, I'm gonna have to do the same. You see they've got these nicks on, so you can just cut along that line there, bend it, snap it off. Obviously just keep the buzz bar itself straight, that's important. And then that'll just go back in there, but it'll just be one shorter. Right, so I've got these buzz bars shorter now, so that will go in there like that. Let's tighten that up. And then this one go in here. When you're doing these ones, you've got to be careful to make sure that the little wire that comes out the back, well, it's not really a little wire, it's quite a big wire, the phase conductor that feeds the tops of the RCDs needs to be firmly connected in still. There's a danger that if you don't do that, you'll get overheating and stuff. So now I hope that this is not going to be an issue. No, it shouldn't be. Obviously this MCB is a slightly different range, not range, but kind of age to these ones. I think this is a slightly more modern one, so it's slightly different size, but in terms of how it should still fit fine. What I'm going to do as well while I'm here is these, you might have noticed, let me just move that up slightly. There's these grey and black and blue and brown conductors which are connected into here. Basically, actually I'll just leave those ones in. Basically there's a 5-core armoured going out to the shed which has never been connected. And I'm going to run some garden lighting in. So I'm going to just put a double socket on the end of this armoured basically. And then I'm just going to run a temporary garden lighting setup from that socket. I'm not going to hardwire anything in because it's not my property, so I'm going to set everything up so that if I need to leave, it's really easy to remove later. But it'd be nice to have that livened up and in use. Right, so I've got my shroud on my armoured here. That's important to remember to do that before you gland it up. I've made that mistake quite a few times before. I'm sure you have to. Let me know in the comments. And then basically this little lock ring goes on the outside like that. And what I do to strip my armouring, obviously I'm just going to measure it so that it can go to the furthest point in the box. That'll be about right. It's always good to have a bit too much than not enough. And then I use this armour slice tool, which has proven itself very, very valuable over the last sort of year that I've had it for. I'll leave a link in the description where you can get yourself one of these. I know that a lot of you guys absolutely swear by these as well. Some of you swear because of them. Because it does take a bit of a knack to get used to it, to be honest. But basically you just run it around, tighten it up a bit, run it around a bit more, and it does a nice neat slice through the armouring. Not all the way through so it doesn't damage the cable, but slices it enough so that then you can easily snap the armouring off. And I use this, which makes it life even easier. So you just slide that down along the armoured cable, and then easy as that. So I've got a bit of hay fever at the moment, unfortunately. I've got a really runny nose. It's pretty disgusting. Right, so that's the armouring sliced off. So now what I do is basically what you need is just a little bit of this sheath stripped back so that you can go around the gland like that. So I try to keep that to a minimum, but about this much will be fine. It just slides off, and then just wind this around. I've bent the armouring a little bit too much on that, unfortunately, but it's fine. We'll get away with it. And then, and as always, there's one tool that I forget. Well, two. My grips, my water pump pliers. And for those of you who are viewing and you're not from the UK, this is basically our standard external cabling that we use. It's got steel wire armouring around it, and that steel wire armouring has to be earthed. It isn't necessarily acting as the circuit protective conductor for the cable, because in this case it's a 3-core, so it's got its own circuit protective conductor within it, but it's more just to act as an earthed metallic sheath for the cable to protect the cable, and then if it gets pierced by a nail or screw or spade or something, then it's more likely to activate the circuit protection, the fault protection on the circuit, and cause the circuit breaker to trip. So that's like that, and then what I'm going to do is put one of these earthing nuts on the inside so that it's all earthed properly back to the board. And this outer sheath will just be stripped back like so. And then I'll identify these later. Somebody told me about these. Apparently these teeth are just to scrape the paint off, and then you're supposed to flip it over. So that's what I'm going to do, and I'm just going to use this gland here as a dummy. And basically just scrape the paint off the metalwork first before I connect the real gland. So here is my zappy. Now obviously these are not the cheapest chargers on the market, and you might think, why are you installing a zappy when, you know, it costs like 800 quid, when you could install a Rolex for like 300 quid. But as you know, I believe in quality. I believe in quality for my customers, and I believe in quality for myself. You know, that's an ethos that that kind of rules the way I run my business. And the thing is about Rolex chargers is there's been so many quality issues that I just don't really believe in them anymore. Plus all the hassle that goes along with actually trying to install one. Whereas these are just so easy. And the quality is amazing. And also, the fact is that I'm recommending these to my customers. If I've got one in my house, that carries a lot of weight. If I turn up on a job to quote for someone and I say to them, yeah, I recommend Zappi, I've got one in my own house, I use it to charge my Tesla every day, then they're going to be like, okay, this guy really knows what he's talking about, and you know, he's not just blagging us to try and sell us something, but he genuinely believes in the product that he's selling. So that's why I believe that it's definitely good. Like for example, Nest products. I've got all the Nest products in my own home as well, because I believe that it makes you so much better installer when you actually use the products yourself on a day-to-day basis. You know all the little ins and outs of them, all the quirks, and maybe the great features that the customer might not even know about. I'm trying to avoid drilling the bricks as much as possible. But I think I'll just have to do one brick anchor at the top, and then the other two will be in the mortar. It's about the best I can do, really. And this is important as well, don't forget to fix that on the back. I usually forget, and then you have to take it off again and put it back on. Super easy to fix up, you just drill a few holes. Use the plugs and screws provided. They got these really nice stainless steel screws with these rubber metal with rubber back washers to seal the whole casing, make sure the IP rating stays good. And my super clips have arrived, so I'm just going to clip the armoured up most of the way here and start getting it terminated in. So these are the LINIAN super clips, designed for steel wear armoured cable between 15 to 18 mil. You can get different sizes, and basically the instructions say you just drill a 10 mil hole and then you just basically wrap it around the cable and hammer it in. So I'm going to give it a go. This is the first time I've used these. I've used the smaller versions before for like FP cable and stuff like that, but I've never used these big super. Right, so I'm nearly there. I've got the armoured all clipped up, as you can see. Looks fairly nice and neat with those super clips. I'm quite pleased with them, and they're really super quick to install as well, which is nice. So now I'm just going to terminate this armoured cable into the charging point, and I'm going to leave a bit of this sheath on just in case later on I have to sort of do any alterations. It's going to make it a bit easier. And I'm going to leave plenty of length on this cable as well. Righty ho, so everything's connected up. So we've got the live, neutral and CPC connected up. Now, important note from Zappi is that you should connect these up with 1.2 Newton meters of torque. So it's important that you have a torque screwdriver when you're connecting these up. My armoured cable is just terminated like that in the bottom, and then I've clipped it down using these LINIAN super clips all the way along, up here, through the wall there, along and into the wall. And then in here I've got my Harvey unit, which is basically a wireless energy monitor that monitors the current flowing through the main tails, and this is what enables our load limiting, so that it never allows the charger to push us over 100 amps when the vehicle is charging. So I've got to pair this Harvey up with the Zappi in a minute. I've done external earth fault loop impedance testing with the main earth disconnected, and all that was fine. I got a reading of 0.24 on that. I got an R1 and R2 reading at the charging point of 0.04, so that's perfect. And I got an earth loop impedance reading at the charging point of 0.31, so all good there. So everything's turned on now, and I'm just going to connect the charging point case on, start pairing everything up, and then we'll be good to go. So this little DIN connector just clicks into the back, and there we go, that tells us that we've got power. Right, so we're just about done. Everything is on and working. Everything's labelled up. I've just redone all the labelling with my Brother label printer, so that's all good. And the charger's working. I'll show you that outside. And here it is, the Zappi. So all sorted, nice tethered unit. The grid indicator there, it's showing my house. I'm currently using 0.1 kilowatts of electricity, so not a lot. And basically, if I plug my tester in, I'll show you how it works. So this is my test unit, which just checks the polarity and functionality of the actual charging point. So I plug it in like that, and then I just press this button to activate the internal contactor. It does an RCD check, and now it says it's charging. And I got 3 red lights, which indicates that the polarity is correct on here. And then I can plug my Fluke multifunction tester into the socket on here and just run the various tests that I need to do to verify that everything's electrically okay. And that's it, good to go. So this is it, guys, all up and running, and I'm super happy with the result. I think those super clips look really nice and neat. It's just nice to not see the cleats, and actually behind the door, when the gate is open, you can't even see the cable, and there it looks pretty neat and discreet. So yep, very pleased with the result. Now all I've got to do, let's go and pick up the car. So let me know in the comments what you think, and if you want me to do a video about the car itself when it arrives, let me know. I might even start a separate channel all about Teslas. But I hope you enjoyed this video. If you did, don't forget to smash a thumbs up, and don't forget to subscribe if you haven't done so already. I post lots of videos about EV charging and the life of an electrician, and if you hit the notification bell, you won't miss out. Thanks for watching, and have a great day.